Education TV. If you are new in this channel, what we do create videos which are educational videos, and these videos are mostly on questions and answers. So here, what our video for today will have emphasis on is chemistry and its calculation on isotopes. So here is an example. An element X has two isotopes of mass 20, and then the atomic number is 10. And also, this element has 22 atomic mass, that's the mass number, okay? And here is the atomic number. So in the ratio of 1 to ratio 3, what is the relative atomic mass of X? So here we have to find the relative atomic mass of these two elements because it's XX here. Because you know that from the definition of isotopes, isotopes are atoms of the same element having the same atomic number but different in mass number. You can see this one, they're the same atomic numbers, but the mass number here is 20, here is 22. So we want to know what is the relative atomic mass, and here is the procedures for you to get the atomic mass, okay, the relative atomic mass of X. So first of all, after written solution, you have to add the ratio. That's 1 to ratio 3. What is the total of 1 to ratio 3? That's 1 plus 3, which is 4. Then the next thing again, you know that these elements, all the elements are 100%. So what you are going to do now, after getting the total ratio, then you divide it by what? The percentage, which is 100%. So you are going to say 100 divided by 4. And when you divide 100 by 4, it will give us 25%. Then from there, element that has 20 as its mass number is going to be this 25 multiplying its own share of the ratio, which is 1, which is going to be 25 times 1, which is equal to 25%. Then for this second element, which has a mass number of 22, is going to be this is 25 that you got here times its own share of ratio, which is 3, which is going to be 25 times 3. And if you multiply 25 by 3, will give us 75%. After getting that, then you are going to bring this into play, which is going to be this 20, which is its mass number. Then you multiply it by what? Its percentage of occurrence, which is 25%. That's going to be 20 times 25 all over the main percentage, which is 100. Plus, also this element, which has what? 22 mass, that is 22, will be multiplied by what? Its percentage of occurrence, which is 75. From there, 22 times 75 all over the same 100. After doing that, 20 times 25 is 500 all over this 100. And also here, 22 times 75 is 1650 all over this down 100, which is the denominator there. And after doing that, you don't have to find any LCM. What you are going to do, just divide them. Since the denominators are the same, you don't have to find any LCM. So here, 500 divided by 100, which is 5, plus 1650 divided by 100 is 16.5. Because if you look at it here, this 100 has 2 0 1 2. Then count it backwards 1 2. The decimal point will stay here. That's how we got this 16.5. And you know that any zero that comes after any number after it is not significant. That's why the zero is not included here. But if you like, you can put it, but it's still not significant. So from there, you are going to have 5 plus 16. So if you are getting any value from this video, like and subscribe this video, and also turn on the notification bell so that whenever we upload a video like this, YouTube will send you notification. So here we are going to have 5 plus 16.5, which is 21.5. Therefore, the relative atomic mass of X is 21.5.